So in this problem, we need to determine the equation of an ellipse whose focus is at the point 2, 3 with directrix given by x plus y minus 2 equals to 0 and eccentricity of 1/2. Let us begin. We'll try to understand the problem graphically first. So we will consider a vertical straight line that will be referred to as the directrix. The equation is given. We have x plus y minus 2 equals to 0. Now, we're going to consider a straight line that is perpendicular to the directrix line, and on this straight line we have the focus with the coordinates 2, 3. By definition, this line on which the focus of the ellipse lies is going to be referred to as the axis of the ellipse. Now, to find out the equation of the ellipse, we're going to consider a point P on the plane containing the directrix and the axis. And the position of point P is very important. It's chosen in a way such that if we take the ratio of the length of PF to that of the length PM, this ratio is always a constant with a value less than 1. And this constant is known as the eccentricity. So our eccentricity, that's equals to 1/2, and clearly half is a value less than 1. What we'll do, we'll use the condition that 2 times PF equals to PM to obtain the equation of the ellipse. Let us begin. So we'll take 2. 2 will get multiplied to the square root of P. So here what we'll do, we'll use the distance formula to find out the length PF. We'll take the difference of the x coordinate, so that's x minus 2. We're going to square it and then add it to the difference of the y coordinate, so that's y minus 3 whole square. So this will be equals to PM. PM is the perpendicular distance of point P from the directrix line. So here what we'll do, we'll use a specific formula to find out this perpendicular distance. Let's go through that formula. We have a point P with the coordinates x1, y1. And we have a straight line ax plus by plus c equals to 0. This is the equation of the line expressed in its general form. We're going to drop a perpendicular from point P on the straight line, meeting it at M. Then this perpendicular distance PM is going to be given by the absolute value of ax1 plus by1 plus c divided by the square root of a squared plus b squared. So here a and b are going to be the coefficients of x and y of the straight line. So that means in our case, we'll consider the absolute value. Inside the absolute value, we'll take the ratio. We'll start with the coefficient of x of the directrix line. So that's 1. 1 will get multiplied with the x coordinate of point P to give the x. Then we will take the coefficient of y of the directrix line, which is also 1, and it will get multiplied with the y coordinate of point P to give us y, and it will be added to x. And then we have the constant term, that's -2, divided by the square root of the sum of the squares of the coefficient of x and y. Since the coefficient of x and y are 1, 1, so that means we take 1 squared and add it to 1 squared. Now what we'll do, we're going to square both sides. Squaring the left side gives us 4 multiplied to x minus 2 whole square plus y minus 3 whole square. So this will be equals to x plus y minus 2 whole squared divided by 2. Now what we'll do, we'll simplify this, and that's going to give us 7x squared plus 7y squared minus 2xy minus 28x minus 44y plus 100. That will be equals to 0. Thus, this particular expression is going to be the equation of the required ellipse with the focus at the point 2, 3. The directrix and the eccentricity is known.